Hi, we want to wrap up our discussion of the model as quickly as possible because we want to be moving on in the next unit to some view controllers and some views so that we can look at this and fully test our model and maybe tweak it a little bit after we have a good view of it. Now, what we're going to do today in this demonstration is to add an assembly. Now, earlier we had said an assembly is really a part, but it's a special kind of part. It's a part that contains parts. So we want to kind of wall off what each of these classes in our model really mean. A part is kind of a template for something that's going to go into inventory. The parts catalog holds these template parts. So a part is only used to do two things. First of all, if it doesn't have a quantity, whether it has a quantity or not, it goes into the catalog. When we create a part, it goes into the pool of useful parts. If it is created with a quantity, it goes into inventory as a number with a reorder level and things like that. Now, an assembly is a grouping of parts that is useful for an assembly line worker, someone that puts these parts together. So technically what we want to do is keep inventory itself walled off to only contain parts, not assemblies. And the reason we want to do this is that when we make an assembly later in our controller, our master controller, or our master model class that reads in all of these classes, wherever we decide to do that, we want to relieve inventory of the parts that go up to make that assembly. So that's, at this point, only interesting. It'll become more interesting in the next unit because we're actually going to do it then. So here's an assembly. This is our header file. It has four properties. First of all, the three strings, I want to talk about those first. We have an assembly name, and an assembly description, and an assembly ID. Assembly ID is the part number, if you will, or the assembly number for that assembly. Now, this begins with this idea of globally unique or application unique IDs. This begins to look like a database. And in Unit 8, we're going to talk about taking all of this model and placing it into a database that we can either source locally on the device or source online through some sort of scripting, server-side scripting, such as PSP or ASP or something like that. But for now, we're going to keep it in classes in our model. Okay, so the three NS strings describe the assembly. The fourth property, the first one I've listed here, is an NS counted set. All right, what in the world is an NS counted set? We know what an NS set is. We know what an NS mutable set is. A set in Objective-C is the concept of a listable object that contains exactly one of each of its constituent objects. We know an NS array can contain many different versions of one object, or many different exactly the same objects of one object. A set, on the other hand, can contain only one of each object, period. A counted set is a mutable set. It's an NS mutable set that applies counting to its objects. So it still only contains one of each object that we put into it, but it also has a count. So if we attempt to put two objects into a mutable set that are the same, it won't do it. It'll error out. But if we attempt to put two of the same object into a counted set, it won't error. What it'll do is say, okay, there are two of this object and one of every other object, let's say. So we've got three methods. We've got add quantity of part, and the quantity is an int, and the part is a part number. We have init with name, assembly ID, and description. And then, of course, like all of our other classes, inventory, catalog, and assembly, we've got a report. So let's look at how we implement these. Here's our implementation. Of course, we synthesize our properties. We also synthesize this property that will be the counted set. Now, init is very simple. It just makes a super init call through to super's init, and then passes in our parameters into our properties. So that's very simple. And then it instantiates self.parts. It instantiates an NX counted set with the initial capacity of 5. Now, I want to take a second here to talk about init with capacities. And we see this in mutable anything. Mutable dictionaries, mutable sets, counted sets, mutable arrays, anything that is a mutable type. This is an initial capacity. The best way to think about this is an educated guess. How many parts, unique parts, do I think that this assembly might have at some point of time? In this case, I pick 5. To be completely truthful with you, I usually pick 5 unless I think there's going to be a lot more, in which case I pick 10. This is an educated best first guess. This is not a hard number. In other words, if we add the 6th part to an assembly, it's not going to break. It's just going to allocate another capacity thing, is all it's going to do. So this is an initial best guess, and that's all I'm going to say about that. Pick a number. Pick a relatively low number. You don't want to initialize a capacity with a capacity of initially 1,000 or 2,000. That should be enough said there. So now we'll go on to this add quantity of part. We could have said add part number with quantity, but this is a little less wordy. In other words, when we call this, we can say add quantity for a part and then the part number. So what do we do here? Well, we're going to be adding the part that many times because in an NS counted set, we know that if we add a part multiple times, it just bumps the count. So all I'm doing here, and this looks a little naive, but actually it seems to be the best way to do this. I have a for loop because the quantity is not a 0-based number, it's a 1-based number. So I have a 1-based for loop, I equals 0, I is less than or equal to quantity, bump I, and then self.parts, add object, and we're just adding that part number. So that's all we're doing now. And then report just prints out assembly, the name, the description that we pass in, and then for every part number in self.parts all objects, now all objects on a set of any kind returns an array of the elements of that set. So in this case, it's the number of unique objects, not the number of objects counted. We get the part number in P, we get the quantity in Q, and then we print out part, and then the part number, and quantity, and then the quantity. And then we print a new line at the end. So the reporting is very similar to the kind of reporting that we see in parts catalog and inventory as well. In the view controller, rather than setting up a whole new interface, because we know all of these interfaces are going to change, they're going to be completely different, but in the view controller, all we're going to do here is test the concept that we have so far of an assembly. So we do this in view did load. Let's see, let's get down to view did load. There we go. So test the assembly class. We're going to make 2 parts. We're going to make a square and a circle. So this we've done, all we're doing here is doing it in code rather than doing it in a faked up interface. So we got PN001 square and put it in bin PR001. And then PN002 is a circle and put it in the same bin. And that's all we're doing here. 2 parts, 1 bin. Now we add it to the catalog. So we add each one to the catalog. Self.parts catalog, add part, square, and circle. Then we add them to the inventory. So add part PN001 and PN002 with a quantity of 100 each to bin PR001. And now we make an assembly. This is assembly, and I'm calling it car. So if we think of a car as being 4 squares in kind of an inverted T pattern with a circle under each end, we have the car 0, assembly PA001, and the description 4 squares in an inverted T with 2 circles below. So now, here we add 4 squares and 2 circles, right? And then we're going to print out our 3 reports. So let's go ahead and talk about that after we run it and make sure that our output looks good. So we'll bring this up. Here's our parts list, our catalog. We have the part numbers for the circle, a part number for the square. The inventory report shows 1 bin PR001 with 2 parts, the circles first and then the square with 100 quantity for each. And then the assembly PA 001 is a car. It is described as 4 squares and an inverted T with 2 circles below. And then we have the part listing for each part. We have 2 of PN002, which we can run up here and see that that is a circle. And we have 4 of PN001. And we can see that what that means is we have PN001 here, we have 4 squares and 2 circles. So everything seems to be working. Now I wanted to talk a little bit here, additionally, about business logic and business rules versus our model logic. Now, we've been using these part numbers and bin numbers and assembly numbers, and we've just said that a part number starts with a PN for part number, a bin number starts with a PR for parts room, and an assembly now starts with a PA. Well, this is okay, but this is an example of a rule that the business brings to the table, or the specific manufacturing concern in this case is saying, okay, every bin number is going to start with PR because the bins are in the parts room, or every part number convention is going to start with a PN because the part numbers are PN, and all of my assemblies are going to start with PA. This is business logic. This is not application logic. Think of it this way. If you are writing an application for one specific business that sets out and says, all of our parts are going to start with this naming convention. We're going to have this naming convention for bins and so forth. If you're doing that, then putting that information of the PN, PR, PA prefix type into the model is appropriate because you're only writing it for one particular manufacturer. However, if you're writing an application that might be used by multiple manufacturers, if you're going for sales, multiple sales of this application, then you divorce business logic from application logic. In other words, you don't say that a PA is a parts assembly anywhere within your application. You allow them to set their own naming convention. Why would you want to do this for a single manufacturer, whereas you would not want to do this for multiple manufacturers? For a single manufacturer, you would do this because it would enable your views and your view controllers to search for specific things. But for multiple manufacturers, manufacturer A might decide to have a completely different naming convention where a number is used as a prefix to a part or even a postfix to a part and a different number used for an assembly and so forth. They will have their own searching rules. In that case, they apply the logic and you can't because you don't know if different manufacturers that you're going to be vending your application to will have different rules. So the basic rule that you should strive for is to keep the model as allowing multiple kinds of ways to use it as possible. So when you design the model, think about vending your application to multiple clients, not to just one specific client. In other words, don't tie down the model in such a way that a part number has to start with a PN prefix. And we haven't done that so far. Notice that anytime we have a part number, it's just then a string that we passed in to make one. And likewise with an assembly and a bin. So we want to make sure that our model is as broad thinking as possible. Don't get so specific that you're tied into it and then you have to write Band-Aid code for another client. So I just wanted to mention that because as we go through and add things to this model, we want to keep our model as as client agnostic, if you will, as possible. Okay, some things to think about there. And we're going to move on now to Unit 7, where we begin to talk about the actual user interface. And I'll show you some tricks that are really kind of iPhone specific in designing user interfaces and applying them to a model like this. Thank you very much.